Welcome to The Next Human. My name is Arav, and today I want to talk about a recent study from UCSD on a new biomaterial to reduce tissue inflammation and heal damaged tissue. Professor Karen Chrisman and her lab published an article in Nature on the evaluation of their hydrogel's efficacy in repairing tissue damage in murine and porcine models that recently suffered from acute myocardial infarctions. In other words, they had heart attacks. But first, what is their hydrogel made of? Well, it's made of the extracellular matrix of the ventricular myocardium. This extracellular matrix, or ECM, acts as scaffolding for tissue to rebuild. Their approach is to introduce the biomaterial intravenously, meaning inside the blood vessels. This approach allows for the hydrogel to be injected immediately after a heart attack because as long as it's introduced into the bloodstream, it can do its job. This is also promising because the bloodstream can act as a highway for the hydrogel to move around the body and ensure that tissue repair will not be localized to one spot. In acute myocardial infarction, blood vessels are damaged, so gaps are formed between the blood vessel's endothelial cells. The researchers assumed that their ECM would flow out through these gaps and directly to the damaged tissue. However, when they tested it in a murine model, they found that instead of passing through the blood vessels, the ECM bound to the endothelial cells, which sped up the healing process of the leaking blood cells and reduced inflammation. In porcine models, corresponding results were also found. This study investigated applying this biomaterial to other conditions too, like brain injury and pulmonary arterial hypertension. But what does this mean? Well, it means that in the future, after more tests and studies, these researchers may have found a way to reduce inflammation and promote tissue regeneration from the inside out. Thank you all for watching The Next Human.